Hey HVAKR users, I wanted to go over a system that is modeled often in HVAKR, which is an ERV system, and give a tutorial on how to set up and tune an ERV system properly. So to start, you've got to zone your spaces correctly. And in a system like this where I've got maybe fan coils served by an ERV, I want my zones to represent that zone level equipment, and then my system is going to be the ERV that's serving all of these. So we're talking about air side processes here. And so all of these zones are getting their ventilation from this ERV. And then in this configuration step here, I'm going to set up the ERV like this. So that is my central unit, and we're going to have outside air coming in, and then we're going to have our ERV component. So with outside air, that's going to be by default the required amount of ventilation that your zones need. The ERV is going to be by default the amount of exhaust air present within this system, within these zones. And I'll show you how to adjust these numbers in the air balancing step even earlier. So these are the two components when setting up an ERV. If you do have conditioning after, if this is kind of like a custom air handler or DOAS unit with cooling and heating after, you can turn on those. But with just these, my outside air method, I'm going to do sum of spaces, which is going to ensure each zone gets exactly what's required. And then with the ERV component on, I've got to set an ERV wheel effectiveness, probably between 60, 70, unless you have a very, very efficient ERV. So we'll put in the effectiveness, and now we are going to model these fan coils. So with this central unit set as an ERV, I'm going to select these, and important piece here is return air is on at the terminal unit. So the zone level equipment is getting return air from the zone. This air coming in, that's going to be the tempered air following the ERV. So with that, how much does each zone get? We want it to also be sum of spaces to match what we're seeing with the ERV. Then I can set up my primary cooling and heating, and let's just call it 55 and 90, and that is the configuration piece. So if I were to jump to my loads report and look at the ERV, I can scroll down to my central data. There's no coil, but I can see the psychrometrics around this ERV, and I can see the airflows by default. And so what this is showing me here on the ERV system is that I have 1300 CFM of outside air. This is the outside air state. I have 710 CFM of exhaust air, or you could call it return going to the ERV. We call it exhaust air because it ultimately gets rejected from the building. This is the state. And so my tempered air state at that 70% ERV effectiveness is here. This is my dry bulb, wet bulb, 86. No other processes in this box, so the air going to my terminal units for ventilation is going to be this 86 degree leaving temperature. If I were to look at one of those now, I can see that at the terminal unit or the zone level, the cooling data, coil, I have this much outside air coming in, and it's already tempered. So it's at that same state as leaving the ERV. So this is showing me the psychrometrics of 120 CFM of outside air at this state is coming into the zone, mixing with the return. My entering air state hitting my cooling coil is as such. I need 55 at 800 CFM. That's going to be the load on the coil to accomplish this. Now, let's look at some of these numbers. So my outside air is at 1300, exhaust is at 710. Where do these numbers come from? Outside air intake, when we configured it, we did sum of spaces, and so that's the calculated ventilation. Ultimately, it goes all the way back to your space types when you set up the ventilation requirements for those space types. Then you model your spaces, and with each space, you're going to get the required ventilation right here. So your zone is going to have a total required ventilation, add that up for the system. That's how we're getting our outside air. What about exhaust in the system? So because all of these spaces and zones are under that ERV system, we're adding up the exhaust present. That also starts with space types when you set the exhaust requirements for spaces. And not every space has exhaust requirements, but our restrooms do, locker rooms do, janitor closets do. And so when you set up your spaces like this one to be a restroom and set the number of exhaust units, it's calculating how much exhaust is required. To get a really quick snapshot of this, you can go to System Design Air Balancing, which is after your configuration, and this is where you can see all those values outlined. So this toilet room, locker room, 400 CFM of exhaust is required, and then in other spaces, you'll see the outside air required. And to see a total, you can go to Systems and see your total for the system. So here, this ERV, 1300 CFM of outside air and 710 rounding of exhaust air present in that system. So what if we wanted to increase this exhaust air to match the outside air and better balance that ERV and make full use of the ERV? Now in air balancing, I can increase exhaust air to do that. You have to do that on a space-by-space basis. You have to actually tell the program where that exhaust air is coming from. You can't just add that to the total for the system, because then it won't know which spaces to pull exhaust from. So one way to do that is to go to spaces, and you could go to your spaces that are already exhausted, like this room, for instance, and 400 is required, but maybe for the sake of the ERV, I want to up that to 600. That may prompt me to also adjust supply and return if I want to balance, but that's up to you. So now with that increased, I can look at my total, and exhaust is now 910. So let's bump it up a little bit more and choose other spaces to pull more exhaust from. And I might bump up all of my regular exhausted spaces like so. Another method is if you don't have enough, restroom space or shower space, things that are regularly exhausted, you could say, hey, I'm just going to pull air from a central location. And so for this open office, just for the ERV, I might add exhaust. I'm going to bring in 200 CFM from here. This also tells me, hey, if I'm pulling this out due to the ERV, then I also want to reduce my return. So this space is actually balanced and I'm reflecting the amount of return back to that fan coil accurately. So with those changes, now my total for the system is 1300 outside air and my exhaust is 1280. I can see it here too. Yeah, about 1280. So it's just about balanced. Less than 100 CFM differential, which is close enough. So going back to my loads for this ERV, now I see that there's my outside air, there's my exhaust, they're better balanced, and so my tempered air, it's in a better state. It's further tempered because there's more exhaust air going through the process that is at that kind of indoor set point, already conditioned state. So with that balancing, I'm going to see an improvement in my loads for the fan coils. My coil load will actually decrease after that balancing process because my outside air coming in is further tempered. And so those steps, it's kind of a pairing. You've got your configuration where you want to set things up properly, and then you've got your air balancing where you want to check those totals, check those numbers. If you need to tune it, this is where you can do that and actually specify, okay, where am I going to be pulling this ERV exhaust air from so that I can make full use of this energy recovery.